Iowa Stormwater Management Manual? Are they, do they work together? Should you just be specifying the use of one or the other? I mean, how do you reconcile those?
Right, that's a great question, and I have a slide on that later, but I can certainly answer it now. So, anything that's covered in the Iowa Stormwater Management Manual, we want to be addressed through the Iowa Stormwater Management Manual. But there are some sections that SUDAS covers that the manual doesn't, like you said, the storm sewer design, those things. And then for those, you would definitely still refer to the SUDAS document to get at. Same way with the river restoration toolbox. That's the new method for working on stream stabilization. So the stormwater management manual doesn't include that, so that's where you go for that information. So that's a very good point to make sure that we get into the right manual to address the right items. Okay.
I'll switch that. And we invite Craig Pierce up.
Well, Aaron, sorry, go ahead.
No, I was going to say, and so Greg's going to obviously go through the unified sizing criteria. I was just going to invite you, though, that if you have any questions or comments along the way, feel free to shout out, and we'll kind of do that as we go versus just wait until the end.
Thanks, Aaron. And just to follow up on what Jennifer said there, in that unified sizing criteria chapter that was sent out, there's section, is it 301, is it 7 or 8? 7? That's got the list of 7. It has the list of, like, if you are a municipality looking to adopt ISWIM, what things should be in an ordinance, or what should you take action on. One of those deals with how to deal with, when ISWIM would take precedence over SUDAS or the River Restoration Manual. So it kind of gives you that pecking order of what should do what.
It's number 14, the last one.
Okay, I'm going to give us a quick tour of the unified sizing criteria. We talked about those ladder levels. We touched on it really, really briefly last week. We just kind of introduced the idea of the Stormwater Management Manual. So Aaron thought it'd be a good idea to let you know, well, what's in the manual already, what do we have a standard in the state, so you can consider, is that something to kind of adopt here in the Des Moines metro area. And as Jennifer mentioned, there's a number of chapters right now that are right on the cusp of being kind of their redo, being approved, and this is one of those chapters that's in draft form. Basically it's gone through several months now of iteration and review, and we're basically kind of at that final point where it's like, okay, everybody's last comments, is there anything left that we missed? And then it's ready to go back to the committee. So in the next couple months, that should be done and live. So, really what are the unified sizing criteria? What is this set of goals that we're talking about? And if you were at some of these working sessions with city staff, we talked about stormwater last year. Some of this may be a little familiar. I pulled in some information that I have, some stuff from ISWIM, and then also some information that Mike Perez, who is the associate professor at Iowa State until just recently, he's now at Auburn, but he pulled together some information too. So really it's this tiered system to manage stormwater. We're not just talking about the big flood events anymore. How are we managing stormwater through the spectrum? So we start with the bottom of the smallest storm events, looking at recharge, and the goal being, hey, let's try to reduce volume as much as we can. Let's do what we can to reduce the amount of water that runs off the site. Because it's easiest to do that with small storms. It's not so easy to do that with the biggest events. The second tier in the teardrop is water quality. So looking at those storms that are about 1.25 inches, and we'll discuss why that is what it is. Looking at those events, and we're trying to capture that water and slow it down and clean it before it goes out to the streams. And then the third tier is channel protection volume, and we're looking at storms that happen about once a year on average. So we're here in central Iowa, you're talking about 2.6, 2.7 inches of rain. So it's a very common event, but these are the storms that tend to create a lot of flash flows in our small streams, and so that's why it's called the channel protection standard. Then the upper tiers, we start to get into the bigger storms that we've probably looked at more traditionally as far as stormwater management. So looking at those 5 and 10 year events, and we're trying to prevent surcharges of storm sewer systems and local flash flood. also the really big storms, so we're looking up to the 100-year and maybe even a little bit beyond. What do we do to make sure that we're not having property damage or for more severe flood effects? So those are kind of the tiers and the teardrop of the sizing criteria, and you'll notice that both graphically and in practice, they're nested within each one. So it's not like, you know, if you start to address water quality and channel protection, you are on your way to meeting the standards for the big storms too. It's not like you have to do this and none of that work counts for the big storm. So they're kind of nested within each other. And in some cases, sometimes you have to treat them separately, but in other cases, you know, there can be where one practice can identify multiple or even all of these aspects of the unified sizing criteria. And really the breakdown of the sizing criteria, we look at both the small storm events and the large storm events. The small ones happen a lot more frequently, so we need to pay attention to them. The large ones, they don't happen as frequently, but they can cause a lot of damage, so we can't ignore them either. So if we divide them into small and large storms, we're going to start by talking about the small ones first. So they're kind of like the bottom, the smallest events, the kind of foundational elements of the unified sizing criteria. And that starts with recharge volume. And the goal of recharge volume is to reduce runoff volume. That's kind of the basic thing. You know, when we install pavement and roofs and we compact the soils, we tend to generate more runoff in the urban environment than we would in the natural landscape or even in the agricultural areas. So the goal of the standard is to try to minimize that effect as much as possible. The target is to look at the 1-inch storm and infiltrate that to the best you can. And the ways you can do that, you know, you can do things like capturing that water, reusing it. You can use irrigation, you know, capture it in cisterns and using it for irrigation, for non-potable uses. You can use you know, green roofs to capture it and, you know, use it on roofs to water the plants there. Also maximizing infiltration on site through either soil quality restoration or then using what we call internal water storage, where they actually, like in systems like permeable pavers or bioretention, you design it so it always holds a permanent amount of water in the rock chamber. So it's either there, it either evaporates, it gets treated, or it gets used by the plant material and it's bioretention. Now, how the draft chapter works right now is this is a target standard, which basically means we would like you to meet the 1-inch, you know, infiltrate the entire 1-inch storm runoff. But in some sites, that's not going to be possible. There are going to be some sites with tough soils or things like that. So we're writing it kind of like, show us that you've done what you can. You know, show us that you can, you know, you've taken these 3 approaches and you've achieved it to a certain level. And if you can't get to that 1-inch, then you kind of work your way up to that very next tier, which is the water quality volume. And this has probably been used a little bit more commonly in the Des Moines metro area. There are a lot more cities that already have this as some type of standard. And the goal is really with the water quality volume is to treat for water quality. So we're looking at a storm event that's 1.25 inches in depth. And how that was picked is basically 90% of the rainfall events in central Iowa are that size or smaller. So 90% of the time when it rains, it's either 1.25 inches or less. So, you know, we just don't think about that a lot, that how frequently those little 1/4 inch, 1/2 inch, and 1-inch storm events happen. But because they happen so frequently, most of the pollutants that are in our water get washed into the streams from those smaller events. You know, every time it rains 1/2 inch, all the oil or sand or whatever washes off the parking lot, down into the storm sewer and into the stream. So that's why it's focused on those 90% events. Plus, it's still a relatively small event. So like if we were going to try to apply some of these approaches and manage, say, a 10-year storm or a 100-year storm, it could get pretty expensive to try to manage that kind of volume. But those storms happen fairly infrequently. They do happen, but fairly infrequently. So it's probably not our best use of money to build practices that manage for water quality from these really, really big rain events. We'd like to focus on the ones that happen most commonly. And the goal is you're going to use best management practices that intercept and treat that runoff volume. So again, some of the things you saw for recharge volume can also apply to water quality. You know, again, capture and reuse, using infiltration, soil quality restoration, permeable pavers, bioretention cells, and bioswales. All those are, you know, practices that can capture that water on site and either infiltrate it into the ground or let it be used by plants. We also allow for water retention to be used to meet your water quality volume, although there are some factors and multipliers that deal with that. But practices like stormwater, wetlands, and wet ponds, if it retains that water in the pool, that can go towards your water quality volume standard. So if you're doing a regional basin and it's going to be a wet pond, that could address it. Stormwater, wetlands can address it. So there have been some communities, just to kind of lay out alternatives that are out there, although there have been some communities that have been concerned that all they're going to get is that type of a practice, or that they're concerned that they aren't going to get enough benefit allowing those ponds and wetlands to be used. So some communities have said it has to be treated with an infiltration practice. Coralville is an example of that, where they wrote that into their standards. So you have to use things like permeable pavers or bioretention cells or bioswales to meet the standard. They won't let you use a wet pond, for example. But the manual gives you that flexibility. So that'd have to be something, if you didn't want to allow that, that'd have to be something you institute either on a community level and a regional level to say, no, we're not going to allow that. And how this is really measured, it's a pretty simple calculation, which is basically you calculate a runoff coefficient, which is based on the I in that formula is the impervious cover on your site. So if you are 40% impervious on your development, you plug 40 into that equation, and that gives you your runoff coefficient. And then you multiply the runoff coefficient times 1.25 inches, and voila, you've got the amount of volume that you have to treat. So that allows you to size the different practices. And because we're kind of high level today, I'm not going to go into detailed examples or engineering on how that is done, but I think you get a sense it's a fairly simple calculation to do. That volume then goes into the different equations to size the different practices to make sure that they're the appropriate size to manage that level of water. So the goal and the result of that standard is to have as little direct surface runoff as possible from these 1.25 inch events. We want that water to go through some type of practice before it leaves the site. It may infiltrate the ground, or it may filter through a bioretention cell and then out through a subdrain, but it's at least been treated and slowed down and cooled before it leaves the site. Typically, the volume that's required to be treated is going to depend on that impervious cover. But if you're talking a site that's say 20% to maybe up to 90% impervious, you're going to be in that 0.3 to 1.1 watershed inches. So if you think of a watershed inch is if you spread an inch of water over the whole area you're draining, that's a watershed inch. So we're talking about, out of that 1.25 inches, you're talking about treating anywhere from about 0.3 of it to about 1.1 inches of it. And how much space do you need? Well, that's a tough thing to answer because it depends on what practice you pick. But one practice that requires a little bit more area than others is a bioretention cell. And typically you need about 5% of the impervious surface area that drains to it. So if you're thinking on a site, how much space do I need to meet this objective? If you took your parking lot and multiplied that area by 5%, and added your buildings and multiplied that to 5%, it'd be about that, size of area. So if you were kind of trying to get some initial ideas on a site plan of how much space you need to meet this, that's kind of a good rule of thumb. So that's water quality volume, and I'm going to talk just in a second about channel protection volume, but you can see here in central Iowa why we use these standards for small storms. So I mentioned that 90% of the rainfall events are 1.25 inches and less in central Iowa. But then if we go up to that next level, the channel protection volume, which is a little more than 2.5 inches, now we're capturing about 99% of all the rainfall events in central Iowa. So the big storm events do happen, but they happen pretty infrequently, and they don't always happen where you have a rain gauge. So that's the point of managing these small storms, because they do happen so quickly that a lot of the effects we see in our local environment are due to these smaller storms, and not necessarily the big ones. So that next tier in the teardrop is channel protection volume. Now we start to shift a little bit from volume, like measuring for a certain volume we're storing, and go a little bit more into rate control. So the goal of channel protection volume is we're trying to slow that water down. We're not going to keep it and retain it necessarily, but we're going to slow it down over a long period of time to avoid that rapid bounce. So that when we get about 2.5 to 2.75 inches of rain, our urban streams don't pop up big and then come right back down, and go back up and then come right down. We're trying to kind of mimic that more natural, where you'd see a base flow where the water and slowly rise and slowly fall. That will reduce the frequency of these bankful events, and it deals directly with urban stream channel erosion. So especially the smaller urban streams that are in our neighborhoods that only drain maybe a few hundred acres, those are the ones that are most susceptible to this kind of effect and what this standard really deals with. Now I should note, we're slowing it down. It doesn't mean that we aren't still letting more water out. So because we have pavement, things like that, even in this event, there will be more volume that goes downstream. We're just slowing it down to a slower rate. So we're not trying to capture and retain the volume. So that's when we get to the ladder and we talk about that balance between number 3 and number 4. You know, we're not quite to number 4 on this. We're not retaining this volume, this extra volume, and keeping it. We're slowing it down. So it's kind of more like a 3.5 if you're looking at that ladder. So before I get into this a little bit, just to give you a little bit of background on engineering, I'm going to try to keep it as light as I can. What's a hydrograph? You know, when we look as engineers